Hello, so in today's video, we're going to answer question 4 from the Edexcel Paper 1 2022 exam. So again, we've done the first questions in previous videos already this week. So again, this is Paper 1 2022 Edexcel A-Level Pure Maths exam. And we're going to answer question 4 today. This question here, that's the question we're going to do. So the first part of the question says, express the limit as delta x goes to 0 of the sum of 2 over x times delta x between x equals 2.1 up to 6.3. So the key thing that we need to remember for this question here is that the limit of a sum is the same as the integral. So the integral of a function is just basically the sum of the products of a small change in x, so we call that normally dx or delta x, multiplied by the function. So this is going to be just the same as the integral from 2.1 to 6.3. Sorry, let me just rub that on, write that again, 6.3. So the integral from 2.1 to 6.3 of 2 over x with respect to x. So that's what that integral would be there. So it's just a case of remembering that the limit of a sum of a function of x multiplied by a small change in x, this dx or this delta x is supposed to represent a small change in x. So if we think about like a graph of this, we've got this graph 2 over x, we've got this function 2 over x, which kind of looks something like this. You got 2.1, which is roughly there. You got 6.3, which is roughly there. So what this is basically doing, the sum there, is it's basically you've got these small dx's there, these small delta x's. So each of these widths here, so each one of those is supposed to be delta x. So that's delta x. So each one of these widths there is delta x. Sorry, let me actually try and do this a bit neater because I want to be clear with this. Just to make it very clear, that each one of these gaps is supposed to be a base of, well, a height or a base of delta x, however you think about it. So each of these gaps is delta x. So you're doing delta x times by your function. So you're basically adding up the areas of these rectangles. That's basically what you're doing. And the integral is basically the area under a curve. So the limit of this sum is going to be the integral. So that's kind of the reason why I mean, that is the reason why an integral is basically a sum. So that's part A of the question done. Then part B of the question. So hence show that the limit of this sum is equal to ln k. Well, I mean, we just written the limit as an integral, which is what we're going to use. So the reason what we've done part A is because we're going to need to use part A and part B. So again, we're going to write out the integral. So the integral from 2.1 to 3.6, sorry, 6.3 of 2x, 2 over x, sorry, with respect to x. So remember, this is just the same as integrating. I'm going to bring the 2 to the front there. So 2 lots of 2.1 to 6.3 of the integral of 1 over x with respect to x. So yeah, this 2 there is just constant. It's just a constant multiplier. So you can just bring the 2 out to the front there. So it's 2 lots of that integral there. And we know that when we integrate the number 1, sorry, the function 1 over x, integrating 1 over x is ln x. So it's 2 times ln modulus of x. And then, well, plus c technically, but obviously we're dealing with definite integration. We've got limits, so we're doing a definite integral here. So we're going to have our limits there. So 2.1 up to 6.3. Okay, so now we're just going to plug in the 6.3 and the 2.1. So we get 2 ln 6.3 take away 2 ln 2.1. So that's going to be our answer there. But the question wants us to write it in the form ln k. So the question wants us to show that this integral equals ln k, where k is just some constant to be found. So we're going to need to use our rules of logarithms to do this. So, I mean, I guess we could factorize out the 2 from both those terms. You get 2 times ln 6.3 take away ln 2.1. Sorry, let me rub that bracket out and do that again. So then now what we get is that this is equal to 2, and then using our laws of logarithms, so ln 6.3 take away ln 2.1. So remember, when we subtract logarithms, we can divide the insides of those logarithms. So it's going to be 2 times ln 6.3 over 2.1 using our laws of logs. And then what we can do now is, again, using what we know about logs. I mean, 6.3 divided by 2.1, that's actually going to be 3. So you get 2 ln 3 And then using our laws of logs again, when we've got a constant multiplier multiplying a log, we can bring that log, that number there, that multiplier inside the power there. So this is the same as ln of 3 to the power of 2, which is ln of 9. And so the integral there gives us a final answer of ln 9. So that would be our final answer to part B. So yeah, that's question 4 done. Just a question getting you to realize that the limit of a sum of a function multiplied by a small change in x, as this small change in x goes to 0, this is it is an integral. That is the definition of an integral. And it's just getting you to realize that, yeah, when you integrate these reciprocal functions, you get logs, and then you can just substitute in your numbers using definite integration to get your final answer of ln 9 there. So that concludes that question, and that concludes today's video.